In this video, we're going to be writing a method called combinewith that'll be adding two int trees together to create a new int tree. So I found this one to be quite interesting. So for example, we have t1 for a tree 1 and t2 for a second tree. And what happens if at the top they both have overall nodes, so we're going to add those two together. And here's the really interesting part. We get the 3 here, 3, 3, 3, but then we get a 1, a 2, and then back to 3, and a 1, and a 2. So what are we actually doing at this point? Well, if you noticed, right here at this node here, the first tree has that has a node there, but the second one doesn't. And we put a 1 there. The reason why we put a 1 there is because it comes from the first tree. Now, why did we put a 3 here? Because we have an overall node that's given there from the first tree and the second tree. So the first tree will always represent a 1, and the second tree will always represent a 2. And if you guys have probably guessed it, but if a node is shared amongst those trees, then we can see that we add 1 and 2 to get 3. If it's not, then we just replace the value in that node with the respective tree number. So let's get started with this coding here. So what are we going to do? Well, we're going to return a new int tree. And we are going to take in a another int tree to combine with. Oh, cannot spell. So we're going to start out with public int tree. Yeah, that's spelled right. Combine with, and we're combining it with a new int tree that we're just going to call other. And what do we want to do in our general method? Well, we know we want to create a new int tree. So it's going to be the resultant int tree here. And the way we do that is by saying int tree result is equivalent to new int tree. As simple as that, assuming that we've already made the public int tree class. So what do we want to do at this point? The way we're actually going to traverse through these things is through traverse by roots. So the way we're going to do that is we're going to say, okay, our result dot overall root, that is going to be equivalent to our private helper method that's going to do all the hard lifting for us. And we're going to say it's going to take in an overall root, and then it's going to take in the other tree's overall root. And what do we want to do after this? Well, of course, we want to return the resultant int tree. Okay, now we got to the private method here. So what do we know that we're going to do? Because we're changing the overall root here, and we're doing the exchange_x method here, we're going to return new int tree nodes every time we go through this method to generate this new tree. And yeah, that's that. So private int tree node. Our method is called combine. It's going to take in an int tree node. We're going to call it R1. Then it's going to take an int tree node. We're going to call that R2. Okay, so what do we want to do in this thing? Well, we should always work with the base cases, and the base case always deals with the root values here. And it checks to see for nullness, I guess. So the first thing we want to do is we want to look at our first tree, and we want to see, okay, is that equivalent to null? If so, let's just work with this case. If so, what do we do? Well, if this is equivalent to null, then we want to see if the other one is equivalent to null. And if we know that these two are both equivalent to null, we're just going to return null because there's no value that we're going to be adding to this new tree. But what if the first IntTree node is null, but the second one isn't? Well, at that point, if you guys remember from the spec here, in this case where we have the node with value 2, we know that this node is contained in tree 2, but it's not contained in tree 1. So the tree 1 has null value here, but tree 2 does not have a null value. So what are we going to return in that data field? We're going to say we want to generate a new IntTree node at this point because we're constructing a new tree. And we want to put the value 2 in, and then we want to actually traverse through the list. And we know that the left is going to be null at this point, so we can say it's null. And we want to check the left side. Then we want to check the right side. Okay. So I think we've covered the two cases that we could have had with R1 being equivalent to null. So at this point, we're going to move on to the else case. So if R1 just so happens to not be equivalent to null, then what do? Well, as we did above, we want to check to see if our second root is equivalent to null. If it's equivalent to null, then we know at this point we want to return a new IntTree node. We're basically doing the same thing we did above, but it's going to contain the value 1. We're going to call combine. We're going to traverse down the left side of the tree. The second value is null. Then we want to traverse down the right side of that tree. Oops. Right. And we need to call upon null, otherwise we'll get an error. Okay, so we've covered that if statement. And otherwise, at this point, this means that R2 and R1 are not equivalent to null. So we will return a new IntTree node that has the combination of 1 and 2, which is just equivalent to 3. And because we know that R1 and R2 are not null, we want to traverse and explore both of their subtrees. So we're going to call R1.left, R2.left. Then we're going to call upon our combine method, R1.right, and R2.right. And are we done yet? No, well, I don't know. Let's see. Okay, if we get into the if statement here, we're going to return null there. We're going to return that. Yeah, return that, return that. Yeah, we're done. Because no matter what, we're going to be returning some kind of value within these if and else checks.